Good morning. I hope you can hear me. Thanks. Thank you all for joining us, and welcome to the 5th class in the course Data Analytics for Students of Social Studies and Humanities. We are recording the session, so if you do not want to be seen or heard in the recording, act accordingly. Otherwise, feel free to ask at any time. My name is Jiří Mírovský. I am from Charles University in Prague. But today I am broadcasting from my home office in Slaný, and I hope my internet connection will be fast and steady. Right at the beginning of the class, I would like to thank Sylvie Cinková. She's been helping with preparation of the class and experimenting with the data and the tool that we will use for weeks or even months. And she will also give a part of today's class. And second, I want to thank Martin Jansen, which is the author of the tool that we will use. He's also been very helpful during last months, weeks, and days, fixing bugs and adding features to the tool so that it's working and presentable. We will continue today the story that often starts with an old box of postcards and letters. First, we catalog what we have in the box, which means we add some meta information to the letters, like who sent it to whom, when was it sent, from where, how many pages it has, and so on. And then, at least for preservation, you scan the letters and the postcards. But if you want to work with the collection further with computers, you need to make them machine readable, which is what we did last class. We transcribed the scans into machine readable text using two tools, Transcribers and Pero. Pero for Czech language, Transcribers for the other languages. If you have not yet finished your homework, please do it soon so we can use the data and go on with the work. Now let me start. Let me share my screen. Can you see my email now? Mm-hmm. Okay. So we will start right where we finished last time, which was in my case, in case of the Czech students, with the tool Pero. I have one page transcribed in Pero here, and what I want to show you that sometimes you need, maybe you experienced it as well. Sometimes it is difficult to read something because it's not a common word, like the signature, for example, may be unintelligible sometimes. So it may be important to consult some external information, maybe sometimes internet, Wikipedia, or in this case, we have the metadata already at our disposal. So I was not sure about this signature. So I had to look into the metadata file and see the name of the sender here, which is Mr. Murko, and the first name starts with M. So I can go back here sorry, I will, yeah, get rid of my email. If I go back here, click on the line. Now I can fix the name. So it was actually recognized quite well. So I guess it's really m dot after m, maybe space and Murko, and enter. And yes, we must not forget to press save. Okay, so the letter is transcribed. Now we need to export it from the recognition tool, so we can use the text further in some other tools. In our case, we export to the Alto format. I hope it will work. Oh, okay. Okay, just to be safe, let's export also the text. It may be useful. And we already have the image, but I want it to have in the same directory, so I will export the image as well. Okay, so for now we are done with Pero. And what to do with the texts further? Today we will work with a tool that is called Taytalk. The name comes from, it's an abbreviation. It comes from Tay, which is an abbreviation for Text Encoding Initiative. It's an international platform for one possible text encoding standard. You can imagine such a thing easily because maybe you know HTML. It's a slightly similar thing, but Tay is more focused on the semantics of the text and less on the presentation of the text. And Taytalk is a tool that works with data in the Tay format. Tok in the name stands for tokenized. The tool Taytalk is focused on working with transcriptions of facsimile encoded and Tay. That's basically its purpose. If you wish, you can work with me on the web page for our course. There is a link to Taytalk login, and also those of you who registered for the class, you should have this link along with your login information in your emails. If not, please let me know by email. I can send you the login information later. So if I click on the link, we get to the Taytalk login page. Yeah, this is my login information. And that's it. We are in the tool. We already have some files there, but now we will add another file, the one that we just exported from Pero. For this, there is an option convert from optical character recognition tool. Yeah, and we will upload a new Alto file. That's not something you will do, or you will not have to do this, so you don't need to remember the steps. But just you have a picture of it, what's needed to be done. So let's find the file in my computer. It's this one. Yeah, and it's been loaded. If I click there again, I forgot the name of the file. I need to find the file here. Maybe Yeah, 8/1872. Okay. So let's go back again. 8/1872. It's this one. Yeah. So it's a file which we exported from the Pero tool, and it's in some auto format. The first step here in Taytalk is to convert it to the Tay format, which we do just by pressing the convert link here. And now the file has been transformed to the Tay format. The tool writes some message that it has not yet been fully numbered. Please click here to renumber the XML. Okay, it asks me to do something that I don't understand fully, but okay, I did it. In Taytalk, one of very nice features is that you have always access to the low format of the text. Like here, if I press that button, I see the text in the Tay format. So if all the buttons and menus and if they fail in some way, they do not have the feature that I need, I can always go to the XML file and do the change manually. So what do we have here? We have the tokens of the text, and we have some reference, especially the reference to the picture. Yeah, that's important. That's what we didn't want to lose. Otherwise, if we wanted only to work with the text, there are plenty other options. But we do not want to lose the reference to the original scanned text, to the picture of the letter or the postcard. So it's here. And even if we later see that this link to some square or rectangular in the image is not precise, if we are brave, we can fix it here. Okay, so this is the representation of the text in the Tay format. Now, if we go down, we see the text here. If we hover above a word, we don't see any additional information yet. And we don't see the picture either. Yeah, we will fix that. We will fix that later. What we can do also is to have a look at the header information or meta information about this file. And we see that we can add some interesting information, like who is the sender, when was the letter sent, who was the recipient, what is the number of pages, and most importantly, we can fill all this if we want, but what we have to do is choose the language. In our case, it's Czech, because then the tool knows which I would say other external tools to use to analyze the text. We can say that it's a handwritten letter. We can fill in some information like the sender. I have it here, so I can just copy it from the meta information we have collected. Okay, some identifier. We have it available here. Just to have it all, let's add also the date, but it's a wrong format, so let me fix also the format. So it's 1922, June 19th. Letter origin. That's also something we might find here. In another column, Prague. Yeah, the letter originated in Prague. Geolocation, I don't know. Recipient, it's of course André Mazon. Number of pages 1. Okay, so now we have added the meta information, which later can be used. And now about the picture. If we press the button images here, we see that the facsimile is missing, and click to add. Okay. It's right here. Let's save it. And now we can go back to the file somehow. Yeah, it's here. And now we can see the scan of the letter too. And we can see the connection between the text and the picture. If I double click any of the tokens, we can see even just the rectangular of the single word. We see the token here, and many more other options which are not yet filled in. We might fill it in manually, like this is a colleague in vocative, and lemma would be colleague in nominative. Yeah, so we can do it manually, but of course it would be a tedious task. There is save button here down. Yeah, so we have the lemma there now, but of course for this there are there are also tools. Let me just do one more thing. Here we have directories for various languages, and the new file appeared here in the top directory. I want to move it to the directory where all the other Czech files are. So I will do it now. Yeah, it disappeared from here and it appeared here along with the other Czech texts. Yeah, and now we can try and run the automatic processing pipeline to get all the information like lemmas, part of speech, and so on automatically. So let's go down, and there is the option Run Dependency Parser. Yeah, let's see if it was successful. And no, yeah, this sometimes happens. Not everything works perfectly here. So let's try the other option, Nlp Pipeline, and run all NLP steps. Maybe we will be more successful. Let's go back. Yeah, and this worked. Yeah. So that's what we've been trying to improve with the author of the tool. And this is the solution. If one of the options doesn't work, there is another one, and at least one of them works, which is great. However, in my experience from last few days, the second option, which was successful right now, has worse results. So, for example, this is in Czech, but this means greatly honored Mr. Colleague, which is invocative, but the tool thinks it's nominative. Never mind. Let's ignore this single text we just imported, and let's try any of the others, like this one. Oh, it's an end of some letter. Let's try the first one. Okay. Yeah, again, what we need to have in mind is that it's an automatic process. The computer does not understand language perfectly, and it cannot recognize all the features 100%. Again, if we look at the addressing here, this means esteemed and dear friend. Again, the friend, I clicked on it, sorry. Again, the friend should be in vocative, and now it's in dative. If we go through all the text, we will see that in most cases it's correctly recognized. Now we had bad luck with two texts where it was wrong. Anyway, if we hover over the token, we see that lemma was recognized correctly, so it's friend. In the token is vocative, but the lemma is of course přítel without the suffix. It's a noun. You see universal part of speech tag, which is the noun. Then the national part of speech tag, which is 15 positional morphological tag, or morphosyntactic tag with 15 positions. And then the next line is morphosyntax, which comes also from universal dependencies. You will hear later from Sylvie Cinková. Yeah, so what we can do if we see the error, we can leave it be, or we can say to ourselves, let's fix it, because it's a small collection of letters. We want to have the information perfect. So let's go here. So it's not dative, it's vocative. Again, here, it's not dative, it's vocative. I guess all the other information is correct. So I save. And now if I hover there, it's already correct. Yeah, we should fix also the esteemed and dear, which should be also invocative, but I guess you have the picture. So that's it. We have the files imported here. Some Czech files are there. There are directories for other languages that we are working with, but they are so far empty, except for French, where there are some files as well already.
No, we have Russian and German as well.
You have added it already. Oh, thanks, Sylvia. So that's Sylvia's work from yesterday. She added also some other documents. Did you add information about the language in the header? Great.
It's parsed. It's been parsed already.
And it's been parsed. Great. But as I don't understand the other languages, I will give you examples in the Czech language. So we have all the all the files here. As you saw, we can go through them one after another. We can work with them. But as the collection is getting larger, it's getting more and more important to be able to search somehow through the collection. And here we have two options for searching. One of them is Cql Search, which is this option here, which is I would say, a flat text oriented search tool. So it does not work with any dependency structure of the text or with the syntax of the sentences. The other tool, Cql Search, here it works with the syntax of the sentence. And what we have here, which is a very nice thing, is a Facsimile Search. Let's start with that. The Facsimile Search uses Cql language for making the queries. Cql stands for Corpus Query Language, and it's a language of CQP system, which is Corpus Query Processor. It's a widely used query language for flat text search. For example, Czech National Corpus also uses the CQL system. Here in the Facsimile Search is not, I can't see the link to the help here, but the same Cql Search here already has the link to help. Yeah. So if you want more information about the language, and I hope you will want, then you can find some help page here. But you need to experiment a little bit, because not all features that are described in the help page actually work here. Yeah. So let's try a simple, very simple query over our text. The simplest thing is to search for just a single token. Let's say today, in Czech dnes. If I press search button, you see the results. That's why it's called Facsimile Search. You see the pieces of the original images here, and it can be also seen that some of them were written by a single person, which is obvious because this is the identification number of the file suggests that it's a single letter with 2 pages. Yeah? The A and B here distinguishes the 2 pages, but it's a single letter. Again here, these 3 come from one document, which is a single page. And this is another one. If we click on it, you see the text, the word in context. You see highlighted in yellow where it was found, and if you hover over it, you can see it in the letter on the right side, which is covered by the pop-up window. Never mind. Yeah, so that's the Facsimile Search. Let's try another word like friend. Sorry. No. Okay. Yeah, here. Here are the results. Again, here, for example, we see that the exclamation mark is a part of the rectangle linked with the word friend, which is not correct. If we wanted, we could go to the XML file, the raw XML representation of the text, and fix this error. Let's go to Cql Search option here. Now we will drop the immediate connection to the scanned images, and we'll work with the text itself, the transcribed text itself. But the query language is the same. Yeah, so again, if I type the simplest possible query like today in Czech dnes, you see the results, not the facsimile, but the words in context. So the preceding context and the following context here. We see that there are 6 results. And if you click on the context here, again, you will see the whole text with the place where the query matched, highlighted in yellow. Yeah, again, let's try příteli, which means friend in 5th case. And yeah, we see the results along with the context. This simple query, just the token in the quotation marks, is actually an abbreviation for a full syntax of the query, which would be in square brackets, and the word equals this. So these square brackets represent a single token in the text, and the features that we write inside represent features of the token. Yeah. So we have word equals příteli. But as we have the text, this is available even if you do not analyze the text further. But we analyze the text using the Universal Dependencies Pipeline, so we already also know the part of speech tag of each token. We know the lemma of each token, and so on. And we can use it in the search. So that we can search, for example, for lemma friend. Yeah, and now we get more results because we get all the forms, possible forms that are in the text of the lemma friend. Yeah. We can try but, the conjunction but, lemma, and no, yeah, what we can see now is that the lemma is with the small letter at the start, yeah, but it matches, of course, also the forms with the capital A at the beginning. But if we write the word is ale, it of course matches only the exact form. But maybe we want to match. We want to search for a word, but we want to ignore the case. There are several options in the query language. Even we can use this directive, which means search case insensitively. Yeah, and we get all the results again. So that's one option. Another option is to use this OR. So we can have word equals ale, but with small a, or the pipe means or the word equals ale with the capital I. Yeah, A, capital A. And let's search. Yeah, and we again get all the results. This, of course, is a general possibility to use OR in specification of the token. So there may be, we are looking for word ale or word like potom, then. I'm not sure if it's in the corpus. Yeah, it's it's there once. Of course, you're free to use lemma here and word here. Yeah. But let's go back to the capital A and the small a. We have solved the problem already, but to demonstrate other features of the query language, there are several other options how to do it. Here, what's in the quotation marks maybe just the text, but also so-called regular expressions. You may have heard of them already or may have used them. They are a powerful method how to match strings with masks, with wildcards. For example, we can say that here at the beginning of the word is either a capital A or a small a. We specify it with square brackets. So if we write on a regular expression, what's in the square brackets stands for a single character in the token. And again, we get all the results we wanted. And the last option, or almost the last option I can think of now, is to use another regular expression feature, which says that this is either ale with capital I or ale with small I. Capital A or ale with small a, sorry. And again, all the results here. So you see, whatever you want to do here, there are often several options how to do it, but regular expressions are the most powerful tool that we have here. For example, if we write P, like the character P and dot, dot stands for any single character, and star, which says the previous character is there any number of times, even 0 times. And if I run this query, it will find all tokens that start with P. Yeah, P standing for Mr. with dot, and then all other words. Here already you can see that we don't get only Czech sentences, because in other languages words also start with P. So we get many results that are not Czech. We may want that if we want to search the whole collection, or we may not want that. So we need to restrict the search. If we want to search only in Czech, we need to restrict the search for Czech language only. It is possible here. I don't remember how it is done. So I need to use this query builder. So I say again that form or word starts with P, and here on the right side, document language, I will select is Czech. And I will press the button create query, and the query is created for me. So the form is P. I hope the form works. I'm not sure if whether this should be Word. It would work with Word, but let's try form. And this is how you say that you only want to search the Czech part of the corpus. And within text is not important. We can delete it. So now if I search, yeah, so form can be used as well. It's good. Now we get only Czech results, unless there are some foreign sentences in the Czech letters. It happens sometimes yeah, like here, yeah, it's a part of a Czech letter. Which is okay. We might try to solve this somehow. If it was happening often and we would want to solve this issue, we have several options. We can, for example, design the corpus so that the language is specified not only on the document level, but also on the sentence level, or even on the token level. Yeah, so it's up to the designer of the corpus what's important. Yeah. Yeah. So now we have all the word forms that start with P. We can do small or capital P. We already know how to do it. Yeah. And as you see, the results are getting quite numerous. So we can go through all of them. It depends what our research question is. Maybe we are interested in which lemmas in the text start with P, or which lemmas are there whose forms start with P. That's actually what we are doing with this query. We are looking for forms, but we want to know which lemmas of these words are represented by these tokens. That's what the frequency options here is for. So we have some token matching the query here, and we can create a distribution table of some feature of these tokens. We can do distribution table of frequency of this directly of the form, or of the lemma, for example. So now we see that there is the count. So 12 times there is the preposition pro, like for in English. This is Mr. 12 times, Prague 11 times. This is to beg or please 10 times, professor 9 times, friend 9 times, and so on. So this yeah, if I go back here, I need to click twice to get back to the query. So this is a powerful tool. If we search for anything, like for words starting with A, small or capital, we can make a distribution table of of any values that are associated with the token, like the lemmas, or if I go back, we can select like a part of speech tag. So we see that coordinating conjunctions are 65 times in the text that start with A, subordinating conjunctions starting with A, 16 times, 10 nouns start with A, and so on. I guess now it is a right time for me to explain the new homework for you. Your next homework will be to go here in Taytalk, look at the text, and think of, I would say, very simple research question, something you would like to know about the text. The purpose of the homework is not to come up with some very clever research question. No, it's desirable, of course, but the purpose is for you to touch the query language, to try and use the query language and to get some result. What might be such a research question? Maybe we want to know in which way the authors of the letters address Mr. Mazon. We know, we've seen some letters already. We know that they address him quite often friend, in Czech příteli. So we say form is příteli, and let's search. Yeah, so we have some results, and we can look directly at what's here in the context. So this is esteemed and dear friend. Esteemed friend. Again, esteemed friend, dear friend, esteemed friend. Okay, but sometimes maybe they do not call him a friend, they call him something else. How can we search for it? Let's try the esteemed here. Maybe something else follows the esteemed. Let's suppose either capital or small v. So we are looking for esteemed. And we have esteemed and dear friend. But here, esteemed Mr. Professor. Again, esteemed Mr. Professor, friend, friend. Okay, so we have several options how to address Mr. Mazon. We could continue this way. We could change this query again that this is either friend or professor, invocative, and try again what can appear here on the left side. And it's interesting. This is slovutný, which means I would say famous Mr. Professor. Again, famous Mr. Professor. So we can go back and there and find out all the possible ways how Mr. Mazon is addressed in the letters. So that's one possible research question you might have. You might also find out that as we have the part of speech and the morphological features available, we might try a query. Let me copy it to be faster. Like we are searching for a noun, And in the positional tag, it's the fifth case marked here. Yeah, so this is the regular expression. We know that in the positional tag, it's here. The national part of speech tag, the fifth position stands for case. Fifth case is vocative. So if we write this this regular expression, the dot stands for a single character. So 1, 2, 3, 4. On the fifth position is 5. Then there is any number of characters following. What I didn't say yet, you don't have to search only for a single word. You can search for a sequence of words, for example. So if you write 2 square brackets following one another, then the first square brackets stand for one token and the other stand for the second token. Yeah, we could also say that this is an adjective. Yeah, so we are looking for a noun in fifth case, preceded by an adjective. Let's search. Yeah, and we have here, it's honored sir, dear friend, famous sir, and so on. This is greatly honored sir. Greatly esteemed sir. Yeah. So so this is an idea of how a research question might look like. Please come up with your own research question. It may be really stupid. If you can't think of anything better, just say, I am interested in which letters, in which tokens my initials appear. Yeah, well, I'm Jiří Mírovský, so my initials are J and M. I want to know in which letters both these characters appear in any order. At least you will have to use the regular expressions and maybe the pipe for the OR operator. So something like that is sufficient. Yeah. So think of your own research question. Try to search for it in the text. You may, if it's a single token search like this, colleague, professor, friend, you can create the frequency of the forms maybe only. Yeah, and this is what I would like you to present as the result. So please, again, use Tableau as a presentation tool for your research question and its results. So what we expect from you now is one page in Tableau that would say, I'm looking for something with this query. Please copy the query there. And this is the result. Not all texts are already here. In Taytalk, please give us 1 or 2 days. First of all, please finish the transcriptions, those of you who have not yet finished them, and then give us 1 or 2 days to put them all there, and then you can choose your language and search in the tool. Okay, so I would say for now, it's all with my introduction to the Cql Search, which is the flat text search. In the remainder of the class, we will have a look at PML-TQ search, very short introduction. And before we start, I would like to ask Sylvie Cinková to be so kind and give us a short introduction to universal dependencies. So now I will stop sharing my screen, and Sylvie, please.
Sure. Sophia had a question.
Okay.
Yes, I do have a question. So first of all, I wanted to ask, is there some like universal symbol or like something that we can use when the word is unrecognizable? Because I've been like transcribing, and I've transcribed it. I've transcribed most of the documents that were in my folder in Transcribus, but there are some words that I can't figure them out. What do I put instead of them? Like if the word is unrecognizable, like do I make some sort of like square bracketed note that this is undefined or something like that?
Good question. In Transcribus, there is a tag you can use that says that something was illegible. Yeah, and that's your case because you are using Transcribus. So that's it. I think I haven't mentioned it in the presentation, and many people used question marks. So this is now totally inconsistent. So if you find the mark, you can use it. But if you use the question marks, it's good enough. Yeah, it would have taken much more training to create a really sustainable collection. So let's leave it as it is. You just had a try on this.
Okay, and the second question: when I finish the transcriptions, do I need to email you, or is it possible for me to upload the PDF and create an XLM or XML document myself in the TikTok?
In principle, if you are interested in how to do that, then give me a call and we'll do this together, since it would take some time to explain. It's not rocket science, but yeah.
Okay, then we'll do that. Thank you.
And it's much better if you give me some indication that you are finished. Since
yes,
I made that mistake that I just supposed that all files would be finished by Sunday night, and then I was painfully finding out that they weren't, and was scrolling through the files which looked like being finished. So I didn't. I have definitely learned my lesson from this. Okay, so let me just connect and link on Amiri and give you an insight into the structure search in the universal dependencies. So Irka said that there is another sort of search you can use, and that's searching syntactic trees. And I will show you the structure of the trees and just guide you through a few trees. It has a separate query language. So to be able to search the trees, you would have to learn yet another. And I also have to give a warning here. While the CQL, the corpus query language, is rather universal and most corpora use it, it's not we are not saying, for instance, the Czech National Corpus uses it, meaning at least the National Corpus uses it. It's really something that's globally used. So with the tree banks, it's a different story. It's much younger than linear search. So there have been many different languages to query them, and also like there were many different tags, there are still many different tags for morphology and different rules for lemmatization for languages. There have been, of course, many different syntactic theories. I bet at least some of you have been studying some linguistics, so you might have heard about the Chomskyan generative grammar, and the French have the dependency grammar by Lucien Tenier. This was, by the way, what you could have read from my lecture, saying if you are really interested, you can read that. So the formalism I'm going to present you is becoming universal somewhat, in that it has become a standard, let's say, in the last decade, and it has a tag set that is cross-linguistically universal, or at least tries to be. Before that, you had to learn a separate tag set and maybe a different syntactic theory for each language. Even if it was in the framework of the generative or dependency grammar, then it was very tightly associated with the classic grammar, school grammar of that given language. So you really had to learn everything separately. In multilingual search, or in multilingual collections like Mason, you would really appreciate having something that you can apply to all the languages. And that's what the universal dependencies are here for. So universal dependencies. I'm gonna share my screen now. It's been an initiative that's been growing, and it has corpora in quite many languages. Now, this is the list of languages. You can easily see that it's both the major important world languages and extinct languages as Latin and ancient Greek, and then small languages like Siberian Komi and some African or Indian languages, and so. So as you see, it's been widely used. It's not only the corpora themselves are not the most interesting thing. They are usually it's Wikipedia or Bible or newswires, things you would not be interested in per se. But these corpora have been used to train automatic tools that you can run on your own text. As you saw in TTalk, we have run a tool to tag each word in each text. So this is the main asset of this initiative. These tools. There's a good tool at our university that's been trained on all these corpora, at least on the bigger ones. And the quality of each language depends pretty much on how big the training data was. So obviously, English, Czech, and languages we have been using and researching on are very, very good, like very much over 90% correct. But if you have something that has only a small training corpus, then the performance is going to drop rapidly or radically. A way out, or if your language is something, if the domain is something very dissimilar to what it's been trained on, if you have a big corpus of newswire and you give it Bible where the language is all different, then of course it's gonna perform much worse than on just another newswire. So these are caveats. And also many digital humanists do make their own manually annotated corpora with this to train on their domain. Unfortunately, it's just a necessary thing to do. If you have big data for which it pays to have a decent tool, you have to adapt the tool. And the developers of this will help you to create or they will create a model from your data. And then you can use it. And if your data was big enough, then it's better than the default you have there. So let me show you what this looks like. So our tool is called UD-Pipe, and you can use it very easily on your texts here, that you just paste a text into this window, or you input a file which cannot be very large, but still more than you would just comfortably copy and paste, or when you are able to write a script, then you don't have to bother with this graphical user interface, but you would use this API. I'm not going into detail here, and we'll just assume that you are not going to use it. So here is my text, and I am going to tokenize, tag, and parse it. Tokenization means I will chunk the text into sentences and tokens, words. The corpus linguists call words tokens or types. Tokens are just all these units you see. Types are the unique words you see. And corpus sizes are usually reported in number of tokens, number of types. So this is my little text, and I'm going to tag and lemmatize and parse. Tagging means for each token I will get the part of speech tagging, and lemmatization is I will get the dictionary form of it. And parsing means I will label relations between the words. Here I have some advanced options. I'm going to use the more advanced UD pipe and tokenized playbacks. This is irrelevant for my case now. So I'm going to do everything to this text. I'll process it once again, and then I get three views of it. This is what comes out of the tool, and what Martin Jansen incorporated in the TEI markup that you have in Tatok. You could see, or would see when you work with Tatok, that it's sometimes clumsy, and it's because it's incredibly hard to unify, to unite this sort of tagging with the TEI stuff. So Tatok is a very special tool that makes it possible for you to stay connected to the images, but it has its own price. If you only have plain text, then you find many much better and more intuitive tools to just manage your textual corpora. This is the same view as the output text, only it's in HTML, so you could see better that it is a table. It is a plain text table, which tells you for each, on each row, these are just, this stuff is comments, but and this as well. But here, this is a proper table, which you can read with your spreadsheet editor if you wish. So ignore this, and let's look at the table. Each line stands for one word, one token. The first column is the ID, and the ID of the token is unique for each sentence. This here, each of these small tables is a sentence, and each token's ID is actually the order of the token in the sentence, as you can easily see. Punctuation marks are tokens as any other. Then the next is form. This is what you have given the tool. Then the next the third column is lemma. So there's not much difference to see, but it's lemma. And then there are two sorts of tags. One is called upost tag, and one is xpost tag. This xpost tag is the national tagging system. If the corpus has it, or if the tool has the can or wants to do it. In most languages, it is like that because the universal dependencies corpora were created from those nationally tagged corpora. So this comes for free, sort of, but should be actually irrelevant. These are the tags that you would have to learn for each language separately. And then this UPOS tag and feeds is the huge leap forward that makes your research so much easier if you work with multilingual material. And it is the universal tagging. The tags, the UPOS tag denotes very coarsely parts of speech. It's slightly different from the parts of speech you learned at school, but not much. It doesn't say anything about cases, persons, tenses. It's just the part of speech. And the labels are, I think, 16 or 17, and some of them are technical things like I don't know what it is, and this is a symbol, this is punctuation. So the real ones are, well, 10. So it's really worth memorizing, and then it makes you very powerful. So this is punctuation. Then for nouns, there are two different tags. It's either noun or prop n, and that means proper noun. So at the same time, UDPipe or these universal dependencies do a little bit of named entity recognition. They won't tell you what sort of named entity it is, but they identify that something is a proper noun, which is, yeah, that's a good start at least. Then a verb is self-explained. Then you have adpositions. It's like prepositions, but you can know that that many languages put something like a preposition after the word. So it's called postposition. So postpositions and prepositions are adpositions. Like the English ago would be a postposition 4 years ago, right? This would be determiner. This is often used for articles in languages that have articles, but it can also be stuff like both, none, these quantifiers, which sometimes, at least in Czech, they count as nouns. But since they behave as determiners, they are called determiners here. And then there are two sorts of conjunctions. This is the coordinative conjunction S-conj, double C-conj, and then there's something like S-conj, like here. This is which is the subordinative conjunction, such as that. I said that would be a subordination. Yeah, and that would be it. The pronouns, there are pronouns here, and could I see anything more? Yes, one more interesting stuff here. Piece. This aux means auxiliary or modal verb. This is a pretty important concept in this formalism. So either you have verb or you have an aux. And this tape, then the coarse parts of speech are further specified with more morphological information. For nouns, there's number, can be gender, can be animacy. This is part of an inventory that's common for all languages, and which you can find in the documentation of universal dependencies. Here for verbs, typically you see that it's mood, so it's indicative or imperative, right? Things like this. Then it is a finite form, it has a tense and the tense is past, etc. Here the languages might slightly, of course, they differ in which which marks they take from the common inventory. When you have a language without animacy, then you of course never use animacy. But they make an effort to use the same marks in the same identical marks for identical or at least highly structurally similar things. Then the next column is called head, and the head points to the ID of a word that this word in question is syntactically dependent of, and I'm going to show it right away. This deprel means dependency relation, and that describes the relation between those two words. Then there's something miscellaneous, token range. This is such a security belt. When the token here you can correct the tokenization if it becomes difficult, then the tool doesn't make it correctly. It simply counts characters from the start of the line or from the start of the sentence. Now I'm not sure. Sentence probably, so you can find borders between words. Now this table gets visualized in the form of a syntactic tree. This is a dependency tree, different from the phrase structure trees. Anyway, it has a technical root saying just root, and then each token is a node in the tree, and each dependency relation, this deprel, is an edge, like this branch in the tree. Like with Lucien Tenier, also this formalism thinks that the verb or the predicate is the top or root, so bottom actually, top of the root of the sentence. So forget about this technical root. The real root is the main predicate of the sentence. In this, we have a very simple sentence here with just one word, one verb, and it is doubtlessly the main predicate of the sentence. So here it is, and then it has arguments. It has a subject and an object, and then some adjuncts, and also punctuation of the whole sentence is governed by this root. Each node has a rich internal structure. This displays just one. You can imagine this as one row in the table you just saw. So this would be the ID. It's the studied is the third word in this sentence, and it. I better take André. André is the first word in the sentence, and it is ruled by the third word. And here you could just link to it that the third word is the word studied. By that they are connected. And it says that the universal part of speech tag is proper noun. It had some English tag. This is the Wall Street Journal, Wall Street Pen Tree Bank tagging format. Is not relevant here. So this is the proper noun, and also it is singular in the features. It doesn't know more, since it's based on the national of this national part of speech tag. It translates into prop noun and number singular, and this also doesn't say anything else. If it were plural, it would be NNPS, but it isn't. So that's how this knowledge is derived. you have the form and the lemma, and then you have the dependency relation to the third word in the sentence. And it says, I, Andre, the first word, I am the nominal subject, noun subject of the third word. So the capital letters, the labels in the capital letters are the coarse parts of speech tags, and the smaller ones are the relations. Why is this important or interesting? Well, it's very powerful if you extract information from big data. If you want to know, if you, for instance, want to extract all events, then you just look for verbs and their nominal subjects or nominal objects, and you can extract predicates, who did what to whom, right away, and then you can sort it or count it, and so you can at least marginally tell right away what the main topics were, or how the authors differed with respect to which events they were describing, for instance. Then so let's go through the sentences so you get the gist of it. So this is the noun. This is the noun subject. Here it says flat. It's a flat dependency. It just says I am a noun of consisting of several words. And although I create some structure here, it's irrelevant. It isn't really a structure. Then slavistics is clear. Then we have Sorbonne here at Sorbonne. The syntactic theories, the dependency theories, they usually agonize over which word of two should be the governing one and which should be the dependent one. And usually they are using tests like, can this word stand alone in the sentence if I leave out, if I omit the other word? So this sometimes works, but with prepositions and nouns, it's always an ad hoc decision, I would say. So the convention here is to, whenever this is so unclear, it's better to put the content words up rather than down, and to hang the auxiliary parts of speech, such as prepositions and conjunctions and punctuation, etc., hang them as children on that content node. So therefore, we have Andre, Slavistics, and Sorbonne, and that would actually suffice if we were interested in what was happening in places, right? We would be looking for a prop noun in an oblique case. This means oblique case. So this is a preposition. Then we could here ask for some typically local prepositions like to, from, at, blah blah blah, and look for verbs that are connected to it. So whether people were fleeing or moving or studying somewhere, that would already be a powerful tool to get this all in one query. So Sorbonne, and another important thing here is coordination. Slavistic, he was studying Slavistics at Sorbonne and the University of Prague. So Sorbonne and University. The language formalisms often differ in how they do this, how they visualize or conceptualize this connection, this coordination. So in university dependencies, the first member of the coordination comes first, the second becomes its child, and the end hangs on the second. So that's something you have to learn, but you learn it once and for all, and then you can just use it. This would be a more a more complex sentence. There you have numbers. He taught at the university and was a professor. So this is a complex sentence already. There are two main predicates: teaching, teach, and be. And I wanted to show you this one, just in case you want to query, you would want to query a tree bank in universal dependencies. It has a somewhat idiosyncratic way to treat copula verbs. Instead of having the be something, this copula be as the other predicate here, right? Here you have teach, and be would be here, and n would be here. That's what we would expect. But because this is a copula, they say, well, it's an auxiliary verb, and let's have the nominal predicate here. What was he? Professor. And it looks horrible, but it's actually because of languages like Russian that don't use copula verbs. And you want the languages to be as similar as possible without inserting artificial notes. So that's why it happened like this. And I see that we are at the end of the lesson, and that's actually all I wanted to show you. If you want to search the tree bank, you would have to call. You would have to learn the PMLTQ language, or a different one. Just Google query a tree bank and select one according to your liking. If you ever wish to have advice or get a kickstart in this, then you can ask me or Jirka how to do this in this PML tree query language. But you can find yourself easily some other ones. So that was it for today. If you have any questions, please. Looks like no questions. So we are looking forward to your homework. I'm going to describe it in a PDF file and hang it on the website to avoid any misunderstandings for the next week. And see you next week then. Bye-bye.
Bye-bye.
Bye. Thank you.
Goodbye.
Thank you.
Thank you. Bye.